Today on Macaulay Math, we're talking trigonometric identities. Intro. Okay, good day. I'm Professor Macaulay. This is Math 150 Pre-Calculus, Lesson 24 on Fundamental Trigonometric Identities. Our goals for today. We're going to use trigonometric identities to evaluate trigonometric functions. We're going to use trigonometric identities to simplify trigonometric functions. And we're going to use trigonometric identities to rewrite trigonometric functions. This lesson and the next couple of lessons will focus on the algebra of how to manipulate trigonometric equations using trigonometric identities. This will involve simplifying equations and proving more complex trigonometric identities. While these exercises can be challenging, they are a great opportunity to revisit previously discussed rules of algebra and apply these new trigonometric functions to those rules. What is an identity? Let's get started with a definition. An identity is an equality relating one mathematical expression A to another mathematical expression B, such that the function A and B produce the same value for all values of the variables defined in both A and B. So, I am oversimplifying. I grant that. But an elementary example of an identity is 3x is equal to 5x minus 2x. Now, most people can say, okay, this simplifies down to this one, and that is true. But it is still an identity because any value that you plug in for x, let's say I were to pick 4, if I went 3 times 4 on that side and went 5 times 4 minus 2 times 4, I would end up with 12 here, and then 20 minus 8 is 12 again. That is what an identity is. So some simple identities are reciprocal identities. We've talked about these already a little bit. Sine and cosecant are related as reciprocals. Cosine and secant are related as reciprocals. Tangent and cotangent are related as reciprocals. The quotient identities tells you that tangent is defined as sine over cosine, cotangent as cosine over sine. And then the Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. Finally, here are the cofunction identities. Since sine, cosine, and tangent all need right triangles, the sum of the other two angles has to be 90 degrees. So looking at the first cofunction identity, sine pi over 2 minus theta equals to cosine theta, makes sense if you pick an angle, say 30 degrees for theta. Then pi over 2 minus 30 degrees is 60 degrees. And the sine of 60 degrees, square root of 3 over 2, is the same as the cosine of 30 degrees. All right, so some general rules for simplifying trigonometric expressions. I put these in here because there's a couple later on in this lesson, but we will definitely be using these later on in future lessons. And these are just rules and suggestions. This is not an algorithm. You're not going to do it each time. And the more experience you get and the more practice that you get doing these, you will be able to see which one of these rules should be used and when should I use it. But one rule that you're going to see me use quite a bit is to change everything into terms of sine and cosine. That's like base principles because the other 4 trig functions are all based on sine and cosine. Use the Pythagorean identities. Anytime you see a trig function raised a even power like squared or to the 4th, you might be using a Pythagorean identity. And then some trig expressions have greatest common factors. Try and factor out some greatest common factors. All right, it says use the given values to evaluate all 6 trig functions. So all 6 trig functions are this. You got your sine, and we got x here, so I'm going to use x. The sine of x, the cosine of x, the tangent of x. The reciprocal of sine of x is cosecant of x, so I'm going to put it next to that. And the reciprocal of cosine is secant of x, so I will put those two next to each other. And then the reciprocal of tangent is cotangent, so I will put those two together. Now let's fill in what we have. I have the tangent of x is equal to the square root of 3 over 3, and the cosecant of x is equal to -2. Well, we can fairly easily solve for two of these other trig functions using just the reciprocal identities. Since cosecant is 1 over sine, we can say that the sine is the reciprocal of this -2. So we'll make this -1/2. And then the reciprocal of tangent, the reciprocal of square root of 3 over 3 is going to give us, let me pull this down and do a little work. The reciprocal of square root of 3 over 3 is 3 over the square root of 3. Now we can't leave that square root in the bottom, so we'll multiply by the funky 1. Square root of 3 over square root of 3. That will give us 3 square root of 3 over 3. And those cancel, leaving us just the square root of 3. So I'll put that right there. Now, how to go about getting my cosine out of what I already know. If I am using the unit circle and my sine value is negative and my tangent is positive. Now think about this. Remember, the tangent of x is equal to the sine of x over the cosine of x. And so we can determine what the sine value of the cosine is going to be based on that unit circle. All right, so think about this. I know that my tangent is positive. So sine over cosine has to be positive, meaning that both sine x and cosine x, and what I mean is positive or negative sine. And so for the tangent to be positive, I can only either be in this quadrant or in this quadrant. All right, now if sine is negative, it can only be in this quadrant here or this quadrant here. So I know for a fact that I have to be in the third quadrant. And so if sine x is -1/2, then the cosine of x can only be negative square root of 3 over 2. Because if the sine of x is half, the cosine of x has to be square root of 3 over 2. It's just the unit circle. Then the reciprocal of that will again put square root of 3 on the bottom. Just doing that real quickly like here, if I have -2 over the square root of 3, I'll multiply that by square root of 3 over square root of 3. That will give me -2 square root of 3 all over 3. And I have them all. Next example. It says use these given values to evaluate all 6 trig functions. So I will do the same thing. I'll go sine x, I'll go cosine x, I'll go tangent x, I'll go cosecant x, I'll go secant x, and I'll go cotangent x. Now I know that the cosine of x is equal to 4 over 5. Here I have the cosine of pi over 2 minus x equals 3/5. Well, if I look at my trig identity cheat sheet and I come down here, I see that the cosine of pi over 2 minus theta is equal to the sine of theta. So I'm going to use that and say that the cosine of pi over 2 minus x equals to 3/5. That basically tells me that the sine of x is also equal to 3/5. So here I can say that this is 3/5. We can take reciprocals for the cosecant and the secant. That'll give me 5/3 for the cosecant, and it'll give me 5/4 for the secant. And remember, tangent is sine x over cosine x. And since the sine of x is 3 over 5 and the cosine of x is 4 over 5, these 5's will cancel, leaving me with 3 over 4. And I need an x here, so 3 over 4. And then the cotangent is just the reciprocal of that, so 4 over 3. And I have all of my solutions right there. Next, simplify the trigonometric expression. So right here, I have the sine of pi over 2 minus x and the cosine of pi over 2 minus x. Those look very much like the cofunction identities. So let's go back up here. Cofunction identities. the sine of pi over 2 minus theta is equal to cosine of theta, and the cosine of pi over 2 minus theta is equal to the sine of theta. So I can substitute for both of these. This one becomes the cosine of x, and this one becomes the sine of x. And then the quotient identity says that if you have the cosine over the sine, you have cotangent. So this is cotangent x. And that is about as simple as we can get. Finally, it says factor the expression and then use the fundamental identities to simplify the expression. So I have secant to the fourth x minus tangent to the fourth x. It says factor the expression. So I'm going to ask you to recall that a squared minus b squared factors into a minus b times a plus b. And I can do that even though that these are fourths. I can say that this is the secant squared x minus tangent squared x. And then this will be secant squared x plus tangent squared x. Now if we go back up to our Pythagorean identities, we can see that 1 plus tangent squared x is equal to secant squared x. So if I subtract tangent squared x from both sides, I get 1 equals secant squared x minus tangent squared x. So I can substitute a 1 here. Then I can use that again, and if you remember, 1 plus tangent squared x is equal to secant squared x. So I can replace this secant squared x with 1 plus tangent squared x. So I have this 1, and then I have 1 plus tangent squared x plus tangent squared x. And so these two can combine, so my final answer, 1 times anything is just itself, and so I'll have 1 plus 2 times tangent squared x, and now I only have one trig function, and there's nothing else that I can combine, so I am finished with that one right there. All right there, folks, that is all I've got for today. So, Star Wars fun fact of the day. Episode 6 was originally titled Revenge of the Jedi, but after a number of movie posters were created, George Lucas thought that Revenge was very un-Jedi-like. So he changed the name to Return of the Jedi, and clearly the rest is history. That's all I got for today, folks. You have a great day. Goodbye.